Energy is the ability of a system to perform a work. In other kind of courses, like physics for instance, we have discussed, or you should have discussed, kinetic energy, which is the energy from motion, the potential energy, and the potential energy is due to a force. It could be a gravitational potential energy, it could be an elastic, it could be electric. Gravitational is very important in this course. Elastic, electric, magnetic, well, we're not going to be dealing a lot with that. And there is another, which is the internal energy. The internal energy is the sum of all the microscopic energies. For instance, it has all the kinetic energy due to the molecules moving. It has, for instance, all the chemical energy, the atomic bonds, the chemical reactions that are happening, all the bonds in the nucleus. So all the microscopic energies are added up to perform the internal energy, and is already quantified. So for instance, the total energies of a system is going to be the internal energy, the kinetic energy, and the potential energy, if we don't take into account magnetic, electric, surface tension effects, whatever, right? So this is going to be, for instance, 1/2 of mass velocity squared with the kinetic energy, and the potential energy mg, and a position at a space which we can call z. And if we take the energy per unit mass, which is a specific energy, it's going to be the internal energy per unit mass plus 1/2 of velocity squared plus g times z. And there is a case where we call the stationary system, where a closed system has the velocity and elevation of the center of gravity constant, which means that the change in specific energy is only going to be the change in the internal energy, because there is no change in velocity, and no change in elevation. So the change in kinetic energy and in potential gravitational energy will go to 0. And energy can be transferred from one body, which has energy, to another. And there are two ways of doing this. The first one, discussed a lot, is work. And work is due to any driving force. And the driving force could be a change in pressure, for instance, mechanical work. It could be a voltage, or change in potential, electric potential. That's electric work, right? Or it could be, for instance, any given force, right? And the other form of energy transfer is heat, and heat is due to a change in temperature. So if there is a change in temperature, then heat starts to flow, and then that's energy transfer. So discussing work, mechanical work, well, the energy that we have, mechanically speaking, is going to be the pressure over density, that's the specific energy, times the velocity squared over 2, that's the kinetic term, plus the potential term. And you might actually remember this from previous courses. For instance, Bernoulli's equation states that there is a conservation of energy, so we can equate two positions in time, or two positions in a pipe and whatever, and equate this, and you can get Bernoulli's equation. While the electric work, for instance, is given as a voltage times a current, right? Which is, for instance, current to the square times the resistance, or voltage to the square over the resistance, and this is the electrical work. And remember that the power is the work per unit time. For instance, the change in work with respect to time, that's the power, or the rate a work is being done with respect to time. And when we talk about heat, there are three processes or three mechanisms, which are conduction, and conduction is due to the particle interaction, convection, and convection it deals with a fluid flow, a fluid that is flowing, and of course it also deals with the particle interaction, but the convection deals mostly with a fluid which is flowing, and radiation deals with emission of photons. And all of this discussion of energy gives rise to the first law of thermodynamics, which states that there is an energy conservation. And this energy which is conserved, well, you can have, for instance, energy which you have inside the body. For instance, that energy that you have inside the body could be the kinetic energy, the potential gravitational energy, the internal energy, and that energy might change from one form to another, and it could be transferred as work. So any change in energy, which could be given as a change in internal energy, as a change in kinetic energy, or as a change in potential energy, could be transformed to work or to heat, right? And there is another expression later on we're going to be dealing with this, which is energy due to a mass which is also entering or going out. But when we're talking about closed system, this has nothing, this does not change, right? But later on we're going to be discussing this term. So this is the first law of thermodynamics.